Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is given majority element part 2. So given an integer array of size n, nums will be your array. Find all the elements that appear more than floor of n by 3 times, and here is the size of the array. So I hope all of you are familiar with what a floor value is. A floor value is nothing but the value that you will get with integer division. Integer division is, for example, you are given, let's say, 14 divided by 3. And then although if you do a floating point division, it will be 4 point something. But when you do integer division, you will get only 4. I hope you are able to understand. This is called floor of 14 by 3. And if you have to find, let's say, ceiling of 14 by 3, then you can do 14 plus 2 divided by 3. It will be your ceiling, which will be nothing but 5. Basically, if there is something after decimal, we round it off. So this is nothing but denominator minus 1. Denominator is here 3. Okay, so I hope you are now clear with what floor value is. So it should appear more than n by 3 times. So if you carefully observe, for a let's say this is our array of, let's say, size 8, n is equal to 8, and the name of the array is nums. Okay, then if you take a floor value with 3 divided by 3, it will be 2, and it should be greater than the number of occurrences of, let's say, x element should be greater than this. So it should be 2 plus 1 at least, and it should be 3 at least. Okay, so how many such numbers who are having frequency 3 can be accommodated in this particular size? Only 2 elements, 3 plus 3. Now you are remaining with only 2 elements, and those will only be having n by 3 occurrences, not greater than that. So only at max you will observe after some taking some examples that only 2 elements, at most 2 elements can be there. At most 2 elements can be there with frequencies greater than floor of n by 3. Okay, this is the major observation that will help us to solve this problem. Now a brute force way to solve this particular problem can be that you can use a hash map or map in C++ and hash map in Java. So what you can do is you can take a number, your element to be your key. It will be your key, and its frequency, element's frequency, as your value. Okay, and then you can easily maintain a hash map, and then you will iterate hash map once, and then you will be able to see which element is occurring, which element is having frequency greater than n by 3, floor of n by 3. Okay, so this is one approach. This is brute force approach. Not exactly brute force, but let's call this brute force for now, because if you see in constraints, it is mentioned that elements array of this nums array, the length of this nums array will be of order 10 raised to power 4, and elements will range between 10 raised to power minus 10 raised to power 9 to 10 raised to power 9. And there is a follow-up that can you solve this particular problem in O of 1 space. So at max the time complexity of this particular approach will be O of n, and here is the size of the array, and space complexity can also be order of n, since if every element is let's say occurring only once, then O of n space will be used, so space complexity will be O of n. So the follow-up is saying to solve this particular problem in O of 1 space. So to solve this particular problem in O of 1 space, new algorithm will be used. If it's new to you, then you should check this article. I will be providing a link of this article. So this article is for occurrences more than n by 2 times. We can easily modify this this particular algorithm for occurrences more than n by 3 times. Basically, for n by 2 times, let's say there is a array which is containing 4 times and then 3 times. Okay, so the overall size of this array is 7, and then 7 divided by 2, it will be 3 plus 1 equal to 4, so at least 4. So you can see that only one element will be there that will be equal to having occurrences more than n by 2 times. So in that case we will check for only one candidate majority element. Here, as you can see, only one candidate majority element is being checked, but as you reduce your number of occurrences to n by 3, floor of n by 3 greater than floor of n by 3, then at max 2 elements can be there. Not necessarily always 2 elements will be there, but at max 2 elements can be there, as we have seen in the example of 8 divided by 3. So 3 plus 3 and plus 2, so 2 elements with frequency greater than n by 3 floor can be there. I hope you are able to understand. So instead of one candidate in this particular Moore's algorithm, we will be considering 2 candidates for majority element. And there will be no such significant change in the algorithm. Rest all things will be pretty much the same. Now let's have a look at the implementation. Let me quickly zoom out. So yeah, what we will do is these frequencies will denote the count of both of the candidates. Initially they will be set to 0. Since at max 2 candidate can be repeated more than n by 3 times, and here is the size of the array, we will check for 2 candidates. Okay, then we will do a single iteration to find the candidates, and then we will do another iteration to verify those candidates if indeed they are occurring for more than n by 3 times. So how we will be determining the candidates? Initially you can set candidates to any random value, like let's say I set them to 23, and this particular one is also set to, let's say this particular one is set to 0. Okay, then initially if your current number that is being that is your current number is equal to, or say current element is equal to candidate 1, then we will increment its frequency, number of occurrences of candidate 1. And if that's not the case, and if your current number or element is equal to candidate 2, then we will increment that frequency of candidate 2. And if the frequency of candidate 1 happens to be 0, then we will uh, set the frequency of candidate 1 to 1, since we have encountered the first occurrence of candidate 1, and then candidate 1 will be set to the current number. Okay, and similarly we will check for candidate 2 also. And if that's not the case, if the current number is neither equal to candidate 1 and candidate 2, then you will decrement both of their frequencies. In that case, the frequencies will be greater than 0, since we have checked for the equal to 0 cases earlier. In this case, frequencies will be, both of the elements will be having at least one frequency, so you will decrement the frequencies. And yeah, that's pretty much it. So this loop will give you the 2 candidates for validation, whether they are occurring more than n by 3 times or not. Okay, then you will do a single traversal again of your given nums array and check their frequencies, and you will set their initial frequencies to 0 again. And if they both are satisfying the greater than equal to size by 3 floor value frequency condition, then you will put them in the resultant array, which you will, or say vector that you will be returning, and at last you will return your result. Okay, and that's pretty much it. Now let's try to submit it once. As you can see, it's getting accepted, and the code will be available in both of the languages, C++ and Java. So, and let's try to convert it into Java also. It can be easily converted, just few minor changes will be there. So instead of auto, Java supports where. I think rest everything will be fine. And here also, instead of auto, where will be there. And then instead of this result being a vector, it will be a list, and we will initialize it with a new array list. And then instead of this pushback method, it will be add. And yeah, I think rest everything remains same. Let's try to submit with sample test cases. There is some error. Okay, since it's a array here, not a vector, so size is giving us error. Instead of that, it will be length. Let's try to submit again. Yeah, it's getting accepted, so Java code will be also there, and I will also try to convert it in Python 3. So if you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. Thank you for watching. Thanks.